Muy buenas tardes. Gracias. I don't actually speak Spanish that well, but I did want to thank you all for being here. It's a real honor for me to be part of the Congreso Futuro. It's been an amazing experience so far, so I look forward to speaking with you here briefly. So my talk today is on sustainable agriculture and resilient food systems. It's an important topic because the food system contributes a lot to some of our environmental challenges. So we need to ask ourselves some important questions about our food systems. So how do we design resilient food systems that take into account population change, shifting diets, climate change, and food inequality? These, of course, are big interconnected issues, and there's a lot of people working on these issues. Now, you're probably expecting me to say that artificial intelligence is going to solve all these issues, but I'm not going to say that yet. I'm going to say that we're going to find some solutions here in a place that you might not be thinking of, the garbage can. I'm going to be talking today about food loss and waste. And if this is not an issue you're familiar with, it has a really staggering impact on the economy in our current food system. Before I get into the size of the challenge, I want to define what the terms actually mean. So food loss is when we talk about food that falls out of the food supply chain, kind of all the way upstream from the consumer. So this can be at the processing plant, in the field, off of the truck. And this is kind of a function of, or the result of, our supply chains being very complex. It takes a lot to get a tomato from California, for example, all the way to New York. And tomatoes can spoil, so it's likely that we're going to have some food losses in our food system. Food waste, on the other hand, is a little bit different because every day you and I are making decisions about the food we buy, how we serve it, that actually leads to food waste. So we participate at the end of the food supply chain, and there's a behavioral component to food waste that we have to consider. Now, when I talk about this scale of the problem, if you haven't heard already, this has been in the news, but about a third of all food is lost or wasted. That means we're producing 50% more food than we're eating and not eating it. It's unbelievable to think about. This represents about 2.6 trillion US dollars in social, environmental, and economic costs. It also, if we think about the amount of land it takes to grow the food we don't eat, it's about the size of China, and it represents about 8% of global greenhouse gases. So this can be a little bit depressing to think about this challenge and how much of an impact it has. But I actually want to think about it from an optimistic point of view. And we have targeted this topic, because it's so important, at the highest level, at the United Nations. So internationally, we see this as an issue, and we've set a target of reducing food loss and waste by 50%. So let's go back through some of the statistics I gave you before and think of it a little bit more positively. Well, if we actually save 50% of the food loss and waste, we don't have it in the first place, that means we have 25% more food available to us. It also means we have $1.3 trillion in potential benefits that we can secure. It means we can reduce greenhouse gas emissions by about 4%, and we can recover the cropland about half the size of China. So I work on this topic in my lab. I think it's a really interesting topic. It's very complex because, as I showed you before, the food supply chain, this can happen all the way from agriculture to the consumer. So I get to work with economists, I get to work with agronomists and horticulturists, I get to work with behavioral scientists. It's a very exciting topic to work on. So how do we look at this issue? Well, first of all, if we're talking about a third of all food being lost or wasted, we need some policy interventions. Clearly, part of the system is not working well, and our food system in many places does work well in terms of what it's designed for. It's designed to deliver safe, nutritious, high-quality food and consistently to the consumer. We do that well, but reducing waste isn't really designed into the system. So we need to think about some policies that can get us to think that way. The policies have to, there has to be some solutions that allow us to hit a policy target. And there's a very distinct hierarchy of solutions that many people have talked about with food loss and waste. The first and best solution always is to prevent it in the first place. In that situation, you're producing the food and someone is eating it. That's what it's designed for. The next solution we can think about is if it doesn't make it to a primary market, we can donate that food to someone. We're still feeding someone, it's still in the food supply chain. Other high-value components or other solutions for food loss and waste include feeding animals, still in the food supply chain, but a little bit indirectly, and some high-value biomaterial and bioprocessing opportunities that I'll actually talk about a little bit later. There are some other solutions that are a bit lower value, anaerobic digestion, compost. Those are certainly better than landfill, but they're actually not included as part of the Sustainable Development Goal 12.3 to reduce food loss and waste. So keep that in mind as you look at this graphic on the right from your perspective. What we did was an analysis of policy in the United States. The green line on that graph represents our target. We need to reduce food loss and waste in every state per person by that green line, 74 kilograms per person per year. Our group used text analysis, stakeholder interviews, and some data modeling to convert every single state policy in the United States into how much food waste we think they will save. The pink lines in the diagram show all the solutions that are included in Sustainable Development Goal 12.3. And as you can see, none of the states will achieve the target with their current policies. If we include some of the lower value solutions like anaerobic digestion, or compost, we see that only 3 states meet the Sustainable Development Goal. So we still have a lot of work to do on the policy side, but it is important for research to contribute to policy to make sure that we're going to achieve our targets. The next theme I like to talk about in my research group is actually the circular economy of food. This is a topic you may have heard of as well. Currently, our food system operates as a linear system. We tend to produce the raw material or ingredients, produce the food item, consume the food item, and any waste goes to landfill. That whole process is a one-way ticket to greenhouse gas emissions. All we do is emit greenhouse gas emissions in the transport of that food, and when we put it in a landfill, it releases methane gas, which is a potent greenhouse gas. If we can imagine another system where we start to recycle the food in the food system, we can use technologies like anaerobic digestion. In the graphic behind me, that blue box is an anaerobic digestion represents an anaerobic digestion facility. What that allows us to do, we don't quite get away from transporting this material, we still have to transport it, but we get to offset some greenhouse gas emissions by producing bioenergy. We get to offset the use of some synthetic fertilizers by taking the nutrient-rich digestate that's produced from the digester and applying it to soil. We get to reduce carbon emissions by locking some of that carbon into the soil. And finally, we get to avoid landfill emissions by putting this food waste to a productive use rather than putting it in a landfill. How we contribute to this particular theme is to look at different components of this circular food system and do research that give people confidence to implement some of these solutions. So for one example, if we roll out a lot of anaerobic digestion, and we have to do this in the state of California, we have a goal to divert 75% of our organic waste from landfill to either compost or anaerobic digestion, supposedly by next year. We're not going to hit that target, but we have to build out a lot of infrastructure to try to accommodate that target. What should that infrastructure look like? We're asking the question, should it be lots of small anaerobic digesters so we can reduce transport distance, or some large-scale digesters so we can achieve economy of scale and maybe have a little bit cheaper access to anaerobic digestion? These are open questions that we have to work on as researchers to contribute back to policy. Another study we're doing is actually testing the efficacy or the success of applying digestate to grow plants. The picture in the lower left of the screen is an image analysis of a tomato plant. And we can monitor the biomass of the tomato plant relative to a control group over time using this sophisticated image analysis. So we apply our tools to give people the confidence to help shift our system from a linear system to a circular system. The third theme we work on is mapping the critical food loss and waste flows. This is all about measurement. We have a saying that you can't necessarily manage what you don't measure. And food loss and waste has been such low-value material for so long, we don't necessarily have a lot of data on this particular organic material flow. So we're working very hard in our research group to work on that measurement from a few different perspectives. One is we have to have clear definitions of what we're measuring. So sometimes I have to go into the academic research and look at what's been produced before and maybe try to leverage some of that data. However, I might find something that says it's 100 tons of corn. That sounds pretty straightforward on the face of it, but do they mean corn kernels or corn on the cob? Is it corn on the cob with a husk, or is it unhusked? We don't know, but those are different amounts of edible food. Those are different materials to work with, so we have to be very specific about what we're measuring. The other thing we need to understand are what are some of the drivers? Why is the food being lost or wasted in the system? remember that the first best approach is preventing food loss and waste. So if we really want to prevent it, let's go to the driver and address the core issue as to why this material is falling out of the food supply chain. Finally, when we measure this material, let's just not measure it in volume. Let's think about what is the composition of the waste? What is the quality of the waste? So is it a rotten tomato or is it a perfectly fine tomato? We can also think about the biochemical composition of this material. If we're thinking about perhaps orange peels, we can think about, well, how much vitamin C or oil can I extract from the skin of the orange? There's lots of different opportunities to think about solution when we shine a light on the material we're actually dealing with. The final piece you have to keep in mind is what I introduced before. We want to know where that food loss or waste is going. Because we have that hierarchy of solutions, if the material is already going to animal feed, proposing a composting solution might not be the best option for addressing that particular flow. So one other piece I want to talk about is zooming in a little bit on that measurement piece. And here, finally, I get to the artificial intelligence component, because this is part of what we're doing as well. So in my lab, we're taking our measurement approach to really understanding the flows of materials, and I've partnered with computer scientists at the University of California, Davis, to help leverage a large natural language processing program they have to collect a lot of data on food items. And this is really biochemical characterization of food items. They've also collected a large amount of data on what the economic value is of all those biochemicals. So we can start to link this information together. How much food is lost in the field? Okay, what is the biochemical composition? And are there some really interesting chemicals or organic compounds that we can extract from that waste flow? Or we go to the tomato processing plant. We're taking the tomato and we're making tomato paste, but we have seeds and skins. What are some interesting compounds that we can extract from that waste flow? What is the value? What is the extraction technology we can use? And is there a business there? So we think that this particular database is going to be very exciting in terms of talking with corporations and talking with policymakers to think about new ways that we can target solutions to food loss and waste. So that is one of our more high-tech solutions. But I did want to share with you all a simple solution today as well. I guess I was behind on my slides. Very sorry. A simple solution, which is to reduce your own food loss and waste. This is converting for yourself a problem to a solution. You can think about throwing food out at your home. We've all done it. Even though I know this issue, I've done it myself. But you can all secure savings. You're basically no longer buying groceries that you're not eating anymore. You can reduce your environmental footprint, all of the greenhouse gas emissions associated with that waste, the water used to produce that food. You can secure that by saving food in your own home, and you can contribute to greater food security by ensuring that there's more food available in the food system. I apologize, I was behind on my slides a bit. I will go back on one just to give you a moment to look at the opportunity we have for the artificial intelligence in food system. This is really collecting the data on the particular crops, the data from the food processing plant, and linking that to the extraction data, biochemical composition data, and the economic value. So thank you very much for your attention. I really appreciated talking with you guys, and everyone go home, think about your food loss and waste, and try to reduce it. You'll feel great about it tomorrow. Thank you.